See Lindelof videos integrating polynomial functions. Here we have this polynomial function. We're asked to find the indefinite integral here. And what I want to remind you is that we can separate this thing using the sum and difference rule from differentiation. We can do that the other way also. So another way to write this would be to write this. Be to write the indefinite integral of 3x squared dx minus, this minus sign is this one, because what I'm going to do is I'm going to factor out that negative 1 right there of dx. So it looks kind of weird, and I kind of get that. What I do to help myself, my little tiny mind, is remind myself that there's a 1 here. Or if you want, there's an x to the 0 power. So what I'm going to do is I'm going to take the indefinite integral of both pieces. So the indefinite integral here, right, to take the indefinite integral, I'll say is equal to 3x to the 2 plus 1 over 2 plus 1 over 2 plus 1 plus c minus x to the 0, because it's x to the 0 here, right, plus 1 over 0 plus 1 plus c. All I'm doing is taking this. I'm really breaking out my work a lot. Actually, I wouldn't show you this much work normally. But if you look at this for a second, right, we're doing anti-differentiation, right, anti-derivatives. So we're doing this whole thing backwards. So usually we decrement when we do differentiation. And here we're going to increment. We're going to increase this by 1. So we would get 3x to the third over 3 plus c. That this is the indefinite integral of this first piece right here, minus 0 plus 1 is 1, so x to the 1 over 1, which is just x, plus c. This gets weird for people, and it really bothers them. Don't let it bother you. Let this be c sub 1 and c sub 2. So this is what we end up with, and it really bothers people. We clean this up, we get x cubed minus x, and if you don't mind, I'll do my c to the c sub 1 plus my c sub 2. And people leave this, but I'm telling you that c sub 1 plus c sub 2 is just equal to c. C sub 1 plus c sub 2 is just equal to c. Think about this just for a second. We're taking the antiderivative of something. So the derivative of any constant will be 0, right? The derivative of any constant. So it doesn't matter what constant I put here. So let's say that this one was 7 and this was 3. I'd have this is equal to 10. And when I took the derivative, well, the derivative of 10 is the same as the derivative of 7, and the derivative of y is equal to 3. It's 0. So it doesn't matter here. So I just put this as c. And I think that's what you're going to see. You're going to see most often. So don't let that bother you. I see people, they collect all these c values. I'm like, there's no need. It's a constant value plus a constant value, which is another constant value, and its derivative would be 0. Let me prove that to you. The way that you prove this, so here's our answer. The way that you prove that, so you say, okay, this is f of x. And if you take the derivative, you prove this through differentiation, right? Proof through diff. I'm going to prove this through differentiation. This is my answer. All I'm going to do is prove this. Now I take this derivative, so I take d dx of this whole thing, and I'll get 3x squared minus 1 plus 0. And isn't that what we started with? I took the derivative of this thing to prove that I did it right, and isn't it right there? So this is not really a big deal. This is something you just have to get used to the rules. You have to memorize the rules of integration and use them and follow through, because what this leads to is something that's really, really cool. So make sure that you get this really well. Hey, thanks for watching. If you have any questions or comments, let me know. And if you haven't already subscribed, please do.